All right, let's talk about something that's kind of like a new kind of digital heist, one where the vault isn't a server, but the AI itself. Welcome to model data extraction attacks.
Now, this is the first part of a 5-part tutorial from Virtualization Options LLC, and it's all for educational purposes. We really recommend you check out the full course document in PDF format. We're just scratching the surface here, and that document has way more detail than we can get into in this briefing. Okay, so to really get our heads around this, we first need to understand the stakes. We're not talking about your typical cyber attack. This is a whole new playbook. $45 million. Just let that sink in for a second. That was the price tag on a single settlement after one company's AI started leaking its own internal documents. This isn't some theoretical threat. It is happening, and it is incredibly expensive.
So that really begs the question, right? How on earth can an AI model, a tool that we built to help us, suddenly turn into an insider threat and start spilling secrets it was never, ever supposed to share? And that $45 million figure, it just perfectly illustrates why this isn't some niche tech problem for the IT department. No, this is a massive business risk. You know, the consequences are severe, and they ripple out across the entire business. You can see it right here. It's not just the immediate cost of the breach. Your stock price takes a nosedive, and maybe even worse, you see a huge spike in customers leaving because that trust, it's just gone.
And check out this quote from that public case study. We're talking about 3,500 internal documents. This wasn't some small leak or a one-time mistake. It was a systematic, prolonged attack where data was just bleeding out. So what is this new kind of heist exactly? It's not like a normal data breach where someone hacks a server. In a model data extraction attack, the attackers are actually just talking to the AI through its public interface, its API. They ask it clever questions, and they coax it into revealing the sensitive stuff it memorized during training. The AI itself becomes the weapon.
So how in the world do they actually pull this off? Well, let's open up the attacker's toolkit. It really boils down to 3 main techniques.
First up, you've got something called model inversion. The best way to think about this is like a digital forensic artist who can reconstruct a person's face just by studying their shadow. Attackers analyze the model's answers and how confident it is in those answers to literally reverse engineer and recreate the original sensitive data.
Next up is membership inference. Now this one's a little different. It's more like detective work. It lets an attacker confirm if a specific person's data was in the training set. It's like asking the AI, hey, was Jane Doe's medical record in that sensitive hospital database you learned from?
And finally, we have model extraction. Honestly, this is the ultimate act of corporate espionage in the AI age. Here, attackers aren't just stealing bits of data, they're stealing the entire model. They just keep asking it questions over and over until they've built their own functional clone, swiping millions in R&D and a company's secret sauce. So when you lay it all out like this, you can really see what the attackers are after. Sometimes they want to rebuild specific data. Other times they just want to confirm if someone is on a list. And sometimes they want the whole shebang, the IP itself. And look at those risk levels, high to critical right across the board. This all sounds pretty scary, right? So it makes you wonder, why are these incredibly powerful, sophisticated AI models so darn vulnerable in the first place? Well, it turns out the very thing that makes them so smart is also what makes them so insecure. The main culprit here is something called overfitting and memorization. It's kind of like a student who crams for a final exam. Instead of learning the concepts, they just memorize the textbook, word for word. Sure, they might ace the test, but if you ask them the right question, they might also recite a sensitive example verbatim. That's exactly what these high-accuracy models often do. And this puts organizations in a really tough spot, what we call the accuracy-privacy trade-off. If you tune your model for maximum accuracy, it's going to memorize more sensitive data, which is a huge risk. But if you tune it for maximum privacy, it might forget critical details and, well, not be very good at its job. It's this constant, tricky balancing act. And it's not just that one thing. There's a whole bunch of other issues that can create the perfect storm for an attack. You know, things like not limiting how many questions someone can ask the AI, having APIs that give away way too much information, or training models on sensitive customer data without the right safeguards in place. Okay, so we've laid the groundwork. We know what the threat is, and we have a good idea of why it exists. But believe me, the story does not end here.
Understanding the what and the why is really just step one.
In the next part of this tutorial, we're going to dive into some devastating, real-world case studies of these attacks in action. We'll look at exactly how these techniques have been used to steal sensitive personal information from major players in healthcare, finance, and more.
And that leaves us with a pretty critical question to chew on until next time. If an AI can be tricked into revealing its deepest secrets, what does that really mean for the future of privacy and for the future of intellectual property?